Hello students, I am teacher Krupa, your maths teacher. Welcome to this one more new video on the chapter Mathematical Logic. In this video, we are going to study a new topic called Algebra of Statements, and also will be solving exercise 1.9 which is based on the same topic. So let's move on. Now, in algebra of statements, what you are going to study is there are some rules of the mathematical logic which can be used to solve the mathematical statements. Using these rules, you can simplify the mathematical logical statements. So, let's start. See, here are the rules given. The first rule is P or P is equivalent to P. The same applies to the AND connective also. P and P is equivalent to P. This rule is known as the idempotent law. The second one is P or into bracket Q or R bracket complete is same as P or Q in one bracket or R. It is also equivalent to P or Q or R. Now, what does this mean? That means if you have used the OR connective between any three of the statements, then out of these three statements, you can pair any two statements together. See over here, they are paired Q and R together, here P and Q is together. So, all these three statements are equivalent. Only thing you have to keep in mind that both these connectives should be of the same type. Same applies to the AND connective also. But here also both the connectives should be of the same kind. P and into bracket Q and R is equivalent to into bracket P and R, P and Q and R, and it is equivalent to P and Q and R. So, any three statements connected by AND connective are equivalent if you pair any two statements together out of these three. This law is called as the associative law. Now, if these connectives are not of the same kind, then what rule will you apply? That is given in the distribution law. See over here. Distributive law or distribution law it is called. P or into bracket Q and R is same as P or Q and P or R. What they have done here? This P gets ORed with every statement inside the bracket. So, this P or you have to pair with every statement inside the bracket with the sign. So, P or Q and P or R, and in between you will put this connective which is between Q and R. This law is called as distributive law. The same applies for the AND connective also. P and into bracket Q or R is same as P and Q or P and R. Understood? Now, what is this commutative law here? P or Q is equivalent to Q or P. That means you can interchange the places of the statements. The meaning of the statement does not change. This is the equivalent sign. So, P or Q is equivalent to Q or P, and same applies for the AND connective also. P and Q is equivalent to Q and P. This law is called as commutative law. See students, you must know these rules by heart, because using these rules we are going to solve exercise 1.9 where it is asked to simplify the given statements using these laws. So, pay attention here. Then the next one is identity law. What is identity law? P or C is equivalent to P and P or T is equivalent to T. Now, you know in OR function, if any one is true, Correct? The answer is true. So over here P or T is true. Getting? Same as in the AND function, if any one statement is false, then the answer is false. So you get P and C is equivalent to C. C stands for contradiction, that is a false statement. So P and C is equivalent to C. And what is this? P and T is same as P. Here P or C is same as P. This law is called as identity law. Next is complement law. P or negation P is equivalent to T. Correct? See, if P is true, negation will be false. So true or false is true. Or if P is false, negation P will be true. So again false or true is true. So this rule states that P or negation P is equivalent to T and negation T is equal to C. This you know. The negation of true, that is tautology, is same as contradiction. For AND connective, P and negation P is equal to C. See this also, if P is true, true and false is false, or false and true is again false. So P and negation P is equivalent to C and negation C is equivalent to T. Next one, law of double negation. Negation of negation P is equivalent to P. This is very simple, all of you know this. Next is De Morgan's laws. Negation of, see now this is very important, negation of P or Q is equivalent to negation P and negation Q. See this negation sign goes to every statement inside the bracket and the middle or sign changes to AND. That is your De Morgan's law. Same for the AND also. See negation of P and Q is negation P or negation Q. As I said earlier, this negation sign goes to every statement inside the bracket and will change to OR. Over here the OR changes to AND. This is De Morgan's law. Then the last one is contrapositive law. What does this mean? P implies Q is same as negation Q implies negation P. This is the contrapositive law. See students, you must know these laws with their names. Okay, because you will be using these laws, and then for every statement where you have used this law, you have to write the name of the law that is used. So remember all these laws with their names. Hope it is clear. Let's start with exercise 1.9. Question number 1 is, without using truth table, show that the first sub question is P double implies Q is equivalent to P and Q or negation P and negation Q. We have to prove this LHS is equivalent to RHS. So let us start with LHS. So our LHS is P double implies Q. Fine. Now we know that P double implies Q is same as P implies Q and Q implies P. That is the law of implication. So let us write it down. P implies Q and Q implies P. Correct? This is called as law of implication, double implication. Double implication. Then now we'll use the law of implication to solve this each bracket. Now P implies Q is same as negation P or Q. Fine, this we have studied. So we get negation P or Q and this sign. Now here Q implies P. So the first term is Q. So instead of negation P, now we have to write negation Q. So we write negation Q or P. This is law of implication. Now students, remember this. You have to write the reason for every step. The rule that you are going to use, you have to write it over here. Otherwise, you will not get full marks. Implication. Fine. Now, see, this is same as in algebra we use the distributive law. A plus B into C plus D. Correct? Here your A is negation P, B is Q, C is negation Q, D is P. So let us solve the brackets. So we will have negation P, now A into C plus D. So this into sign we have to use here, that is and negation Q or P, correct? A into C plus D plus B into. So plus sign is over here or. So Q into and, correct? Your into sign is and. Negation Q or P. This is called as distribution law. Fine. Now by the same rule now let us solve these brackets. So you get this is equivalent to, now this whole thing you will take negation P with the sign, you have to multiply with each term in the bracket. So you get negation P and negation Q, then this sign or negation P and P. Correct? Let's put this in one square bracket. Then this middle sign or into another square bracket. You will get Q and negation Q. So Q and negation Q. Correct? A into B plus, that is and sign, Q into P. Same law, distributive law. Also what we get here. Now see negation P and negation Q. So that we'll write as it is. Negation P and negation Q. Or now over here, see negation P and P. Suppose P is true, negation P will be F, or if P is F, negation P will be true, and true and false is false. So we write here C. C stands for contradiction, that is false. And into another bracket, again here Q and negation Q. So you get false, that is contradiction, or Q and P. Correct? This law is called as, what is this law? Complement law. Okay, now let us simplify further. So again here, this is this bracket or C. This is C or C. Now you know that with OR function, if there is C, that is false, you get it is equivalent to the P. So here your P is negation P and Q. So this is as it is, negation P and Q, or in this bracket again same thing, C and P, sorry, C or P. So it will be P. That means you get Q and P. Same law. What is it law? This is identity law. Now see what is given over there, negation P and Q, and in the first bracket P and Q. So we have got the brackets, only the thing is they are in the reverse order. So we have to bring this bracket first and take the first bracket to the second position. So that is the commutative law. So we can write this as Q and P, or negation P and negation Q. It is commutative law. Again we want P first and then Q. So we'll just again apply the commutative law and make it as given in the question. P and Q or negation P and negation Q. Same. And this is nothing but equal to your RHS. So we have proved LHS is equivalent to RHS. See students, I know it is a bit confusing, but with practice you can solve easily this type of questions. Only the practice is required. Fine. So now let's move to the next sum. The second question is P and into bracket into round bracket negation P or Q or negation Q, and this should be equivalent to P. This is what is the second sub question. Now let us start with LHS. Okay, so you get LHS is equal to P and negation P or Q, fine, or negation Q. This is what is given. Now we have to prove that this is equivalent to P. Now so you can see over here in this there is only one same connective or, but we have here Q and here this side there is negation Q. So what we can do is using the associative property we can put this Q and negation Q in one bracket. So we write this is equivalent to P and into bracket negation P and Q or negation Q. Have you understood what I have done? I have paired this Q with negation Q in one single bracket I have put. This is your property called as associative. Associative law you can write. Fine. Because now Q or negation Q, you know what it is. Q and negation Q, or it is. So it will be T. So we write this is equal to P and negation P or T, that is tautology. This is called as complement law. You must know these laws by heart. Complement law. Now negation P or T, you know it will be T. So you get P and T. What is this again? Complement law. Sorry, this is identity law. Identity law. And P and T is again and it is. So it will be equal to P. That is same here, identity law. And this is nothing but here RHS. So this was very simple. Therefore we can write LHS is equivalent to RHS. Understood? That's what I said. If you practice more and more, these sums will be more and more easy for you. Let's move to the next. See the third sum, students. Negation of into square bracket into round bracket, we got P and Q. Round bracket complete implies negation Q. Complete the square bracket. This should be equivalent to P and Q. Now see, let us start with LHS. So let us copy the LHS first. Negation P and Q implies negation Q, bracket complete. Fine. Now see over here, this is nothing but your negation of implication. Correct? Negation, you can consider this bracket P and Q as a single function, say P. So it is same as negation of P implies Q. And negation of P implies Q is P and negation Q. P is what? This bracket. Q is negation Q. So this is same as P, that is P and Q and negation of negation Q. This is your law of negation of implication. Sorry, law of negation of implication. Fine. Then the next one. Now we know that negation of negation is the statement itself. So your negation of negation Q you will get equal to Q. So we write P and Q and Q. What is this law? Negation of negation. Very simple sum. Negation of negation. Now what you can do? Put this Q and Q in one bracket. Using which property? Associative. So you get P and Q. This is your associative property. Now what will be Q and Q? It is Q itself. So P and Q. What is this rule? This is idempotent law. The very first law that we have seen in algebra of statements. So idempotent law. And this is nothing but your RHS. Very simple sum. If you know all the laws, this type of question is very simple. That's why I said practice, practice and practice. So we can write therefore LHS is equal to RHS. That's all. So students, as I said, this exercise is a bit confusing and quite lengthy also. So what I will do is I will stop here and the remaining sums I will be solving in the next video. So till then you keep practicing and keep revising the rules and the sums that we have done today. Fine. So if I am sure you have liked this video, so like it, share it and subscribe my channel and also press the bell icon to get all the notifications of this channel. Thank you students. Keep practicing, keep enjoying maths. Goodbye.